And I am very excited to introduce our final keynote speaker. Trey came into Python through a project that he agreed to help out with that happened to need it, and ultimately fell in love with the language. He became interested in teaching Python to others and began running workshops. Finding himself unable to provide individual tutoring, he eventually started Python Morsels, a skill-building service for Python developers, which provides a weekly hands-on Python exercise. Outside of Python, he's interested in considering practical ways to make the world a better place for humans and learning about public policy and economics from the standpoint of a non-public policy or economics nerd. He's an avid listener to audiobooks and podcasts, and he enjoys spending time with his wife, who he met at a Python meetup, and his two stepkids. It is my very great pleasure to introduce to you Trey.
That was the best introduction I think I've ever been given, so thank you, Kattni. Our brains are amazing, but they're far from perfect. Let's say you're a baby, and you're participating in a developmental psychology study. The researchers running this study need some way to measure what you're thinking. They decide to pay attention to what you're looking at. What you're looking at is a proxy for what you're paying attention to. Something might catch your attention because you find it interesting or lovely. It's something that your brain prefers. Or it might catch your attention because it's surprising. Your brain is paying attention to that thing because it's different than you expected. Our brain pays attention to what it pays attention to. Sometimes we control our attention consciously, but most of the time, changes in our attention happen automatically. For both babies and non-babies, our brains are constantly processing, predicting, and reacting to the world around us. Our brains are trying to make sense of our environment so that we can better respond to it. But your brain doesn't directly experience the world around you. Your brain is constantly modeling the world. And it does so flawlessly. Not flawlessly, flawfully. Not flawfully, falafely. Fluffily? Never mind that thought. What I'm trying to say is that words matter. That's not actually what I'm trying to say, though I might say that later. What I'm actually saying is that your brain is lying to you, but it's doing the best that it can. One of these faces is white, and one of them is black. One has a dark background, and one has a light background. But that's not right. These faces are the same color. These faces are both a shade of gray that's directly in between white and black. This optical illusion happens because our brain is trying to correct for what it perceives in a difference in the quality of light around these two faces. Our brain is modeling the world. And much of the time, the models that it makes are helpful, but sometimes they can lead us astray. I'd like to think about our thinking, which you can think of as metacognition. That's not quite what metacognition means to academics, but I'm not an academic, so I will happily misuse this word. When it comes to thinking about thinking, I am a learner, a dabbler, and a hobbyist. I listen to a lot of audiobooks and a lot of podcasts that are in some way related to thinking about thinking. But this isn't just a hobby for me. I teach Python, and I helped form the Python Software Foundation's Code of Conduct work group. Learning about learning helps me teach better. And in the Code of Conduct work group, I spent time reflecting on language, people's intentions, and how our behavior is perceived. This talk has three parts. First, we'll acknowledge our own cognitive biases. Then we'll appreciate that our brain is constantly making models of the world. And then we'll consider the gradual nature of progress. If you import this at a Python prompt, you'll see a poem printed out. This poem is called The Zen of Python. Steph referred to this in her keynote yesterday, and Paul had a whole talk on this earlier this afternoon. I often tell my students that each line in this poem could be seen as an opposition to at least one other line, which means this poem can't be used for ending arguments, but it can be used for starting arguments. Like the Zen of Python, I hope to start a conversation, not to conclude one. I don't have many solutions for you, but I do have a lot of questions. Our brain loves patterns. Patterns help our brain take shortcuts. Our brain is pretty adept at taking reasonable shortcuts most of the time. But all shortcuts are prone to systemic errors. A few weeks ago, I recorded a bunch of short video clips, and then I realized that I had accidentally recorded my mouse cursor, which I did not want to be included in these clips. I had spent about 30 minutes recording these clips. I then spent about 30 minutes trying to edit my mouse cursor out of these clips. Unsurprisingly, I did not succeed. I am not an experienced video editor, and it definitely takes me more than 30 minutes to edit a mouse cursor out of half a dozen video clips. So I then gave up on editing, and I re-recorded every video clip that had a mouse cursor in it, which took me less than 30 minutes. Why did I spend the time trying to edit my mouse cursor out of those video clips? I posted about this situation on Mastodon, and a cognitive science professor pointed out to me that I was experiencing the sunk cost bias, which I would sum up with the phrase, "I've come this far, so I can't give up now." The sunk cost bias is just one type of cognitive bias. The phrase cognitive bias was invented by two psychologists in 1972, Amos Tversky and Daniel Kahneman. Cognitive biases are shortcuts that our brain takes, which occasionally cause us to make errors in judgment. In the book, Thinking Fast and Slow, Daniel Kahneman talks about System 1 and System 2, which you can think of as fast thinking and slow thinking. Fast thinking involves fast and nearly effortless mental work. Slow thinking involves slow and deliberate mental work. It might seem like slow thinking is better, but slow thinking requires more energy and more time. Fast thinking is absolutely necessary, but it's also the cause of many of our cognitive biases. The sunk cost bias is just one of many biases. Some others include the bandwagon effect, which is also the name of a front-end web framework which was released just before this talk. Everyone loves it. You should go home tomorrow and rewrite your entire code base to use it. There's also confirmation bias, which involves seeking out information that confirms our existing assumptions or beliefs. This happens when we try to validate our assumptions instead of trying to invalidate them, which is related to a common problem when testing your code. Years ago, I made an application that had great code coverage, and we'd thoroughly tested it. And then our first user tried to sign up, and it broke. Our first user had apparently been born on February 29th. And our age validation logic had a bug which resulted in an exception just for February 29th birthdays. We had confirmed that our birthdays worked, but we hadn't thought of all the edge cases. You know what might have helped? Quality assurance. A good QA engineer knows how to break applications. They try out interesting birthdays, like February 29th. They enter odd email addresses. They use emoji characters, but not just any emoji characters. They use the ones with zero-width joiners, which often break code, which, in fact, Python 3.13 just recently had a bug related to a zero-width joiner. Questioning your own assumptions is difficult. The next time you could use some help working around your own confirmation bias, talk to a friend, or walk through your code with a rubber duck, or ask a chatbot what assumptions you might be making. To overcome our natural confirmation bias, we need to question our beliefs instead of trying to confirm them. An anchoring bias occurs when our brain inadvertently anchors our thinking on a specific piece of information which can sometimes cloud our judgment. For example, Steve Jobs announced the price of an iPad by displaying $999 on the screen behind him for many seconds before eventually announcing that an iPad would cost $499. That immediately made iPads seem inexpensive. The anchoring bias doesn't just apply to prices, though. Let's say your manager asks you how long a new project will take. They say, "Can you get it done in 13 weeks?" And you respond, "Sure, we can get it done in 8 weeks." What if they had instead said, "Can you get this done in a week?" you're likely to say something like, absolutely not, this will take 4 weeks. Overcoming the anchoring bias takes a lot of very slow and very deliberate thinking. Our brains tend to prefer the way things are, especially when a situation is complex or when outcomes are uncertain. The way things are is the default, and defaults are easy. This is called the status quo bias. But our brains don't always prefer the way things are. We also have a tendency for action. So our brains are susceptible to an action bias, especially in high-pressure situations. But even when we don't like the status quo, action is not always better than inaction. There's a principle related to this bias. It's about fences. Let's say you acquire some land, and on that land you find a fence. You don't like the fence. Not a pretty fence, and it has a very strange location. You don't understand what purpose this fence could possibly serve. Should you tear the fence down? Chesterton's fence is the idea that you shouldn't take down a fence unless you try to understand why the fence was put there in the first place. This often comes up in legacy code bases. If you find some code that seems unnecessarily complex, it might be. Maybe it is unnecessarily complex. Or maybe there's a good reason for that complexity. Sometimes something seemingly unnecessary is actually necessary. So Chesterton's fence is a principle about overcoming the action bias. But it's also related to overconfidence. The overconfidence effect and the related Dunning-Kruger effect are both about misalignments between our perception of our abilities and our actual abilities. Though the Dunning-Kruger effect is actually just a natural part of gaining experience. The more we know about a topic, the more we know how much we know about that topic. When we're first getting started, though, we know enough to be dangerous, meaning we have a tendency to think that we're more skilled than we are. It's extremely difficult to notice our own overconfidence without some sort of outside input. Now, for abilities that are quantifiable, like your typing accuracy, you can probably take some sort of test. But for abilities that are hard to quantify, like professional skills or social skills, you'll need to seek input from others, ideally as many as you can. According to David Dunning, one of the best ways to counterbalance your overconfidence is to team up with others who might be able to notice and point out instances of your overconfidence. Related to the overconfidence bias is the not invented here syndrome. I see a lot of heads nodding for this one. Why would I use code that originated outside of my organization when I could write the code myself? This is definitely a bias that has affected me. As a Python programmer, when I have a problem, I often think of solutions to my problem that involve writing code. I have written Python programs to help me reconcile my finances and get my taxes in order. Could I have used off-the-shelf software to help me with these problems? Maybe, but I didn't. Instead, I wrote code. Sometimes Python is a hammer, and all of our problems look like nails. Many years ago, I was working on a Python project that needed to serialize JSON data. Today, I would have solved my problem by using the JSON module in the Python standard library. But at the time, we were using Python 2.4, which didn't have a JSON module, at least not yet. There was a third-party simple JSON library, which later became the official JSON module. But I chose not to use that. What did I do instead? I wrote my own JSON formatter. Now, in hindsight, this was completely ridiculous. I had no good reason to write my own JSON formatter, but I did it anyway. I think of not invented here as not thought of by me. Instead of asking your coworker for help brainstorming a problem, you decide to solve everything yourself. But what if you don't even have a coworker to ask for help? Well, there's always a search engine, and since we live in 2024, there's always a chatbot. Of course, you should not assume that a robot will give you the right answer. But you also shouldn't assume that the code you found on Stack Overflow is correct. You do need to verify that your solution works, but that doesn't mean you need to invent everything yourself. I've had colleagues remind me for years to stop building things myself. I do still build things myself, but I'm not afraid to ask for help. I perform about 500 searches every month, which is over 15 searches a day. I also start a new chat conversation with a large language model at least once a day. There is no shame in using Google, asking a coworker for help, or using a chatbot. In fact, not seeking help may be a liability. We can't completely overcome our cognitive biases. Most of our thinking involves mental shortcuts by necessity, and mental shortcuts always have a risk of an accidental bias. Now, while we can't always avoid our biases, recognizing them can help us react to them and work around them. Though it's a lot easier to recognize a cognitive bias in someone else's thinking than in your own thinking, which of course is another kind of cognitive bias, the bias blind spot. So try to focus on recognizing your own biases. You can't get rid of your biases, but you can try to respond to them. The next time I notice a mistake in one of my videos, I think I might remember publicly admitting my own sunk cost bias on stage at PyOhio. And hopefully I'll pause for a moment to seriously consider whether I should edit my video or re-record it. Let's say we have a list, an empty list in Python called x. What do you think this might do? What's your guess? X.append x. Is it an empty list? A list with an empty list inside it? Something else? It turns out it's a list that contains itself, because that's possible in Python. A list can contain itself. Well, sort of. A list can at least contain a reference to itself. Python is smart enough to represent that list using 3 dots, because otherwise it would need to show an infinite number of square brackets. Interestingly, that string representation is also valid Python code, though. It represents a list containing Python special ellipsis object, which is a bit odd. I call this kind of code a Python oddity. When I say oddity, I don't mean a bug in Python. I mean something that might catch you by surprise, especially if you're newer to Python. A good Python oddity will help reveal that the way that you think about Python differs from the way Python thinks about itself. I collect Python oddities because they help me and folks learning with me challenge our mental models of Python. Every concept in our head has some sort of mental model attached to it. Our brain forms mental models implicitly, but it's often helpful to make our mental models more explicit. Deliberately considering our models can help us discover where our mental models of the world break down and where they don't. Let's test your mental model of Python's variables. Let's say we assign a variable to an empty list. Then we'll assign another variable to the first one. Let's say we then append 9 to the first list. So the first list now has 1 element in it. How many elements are in the second list? 0 or 1? Think about it for a moment, commit to your guess, and have it in your head before I reveal the answer. 0 or 1. So the answer is this second list has 1 element in it. Let's compare a few different mental models to see if any of them explain what's going on here. So the first mental model we'll try is one that models variables as buckets that contain objects. If we assign a variable to an empty list, that variable contains that list. Then when we assign another variable to the first one, that list is copied into a new bucket. So let's say we then append 9 to that first bucket, which would mutate the first list. But the second list shouldn't change. Now we've already seen that it does change. So this mental model doesn't work, at least not in Python. In Python, variables are not like buckets that contain objects. So let's try out another mental model. Let's mentally model a variable as a sticky note on an object. When we assign a variable to an empty list, we attach the name of that variable to the object. And then when we assign another variable to the first one, we simply attach another name to the same object. So when we change the first list, the first one changes. But the second one also changes, because it's all just one list. This mental model works pretty well. But what if we put that list inside another list? At this point, should we add another sticky note that says which list it's in and which index it's at? And what if we point another variable to that outer list? Do we need another sticky note? This is getting complicated. This mental model works pretty well for explaining how variables work in Python, but it doesn't work very well for explaining how objects and data structures work. So let's try out a third mental model. Let's mentally model variables as references or pointers. We have two worlds, variable land and object land. Variables all live in variable land, and they point to objects that live in object land. So when we assign a variable to an empty list, we point that variable to the new list object. And then when we assign another variable to the first one, we point that second variable to the same object. So if we modify that first list, the first list changes. And so does the second, because they're the same list. But wait, why does our list have an arrow pointing to an integer? Well, just as variables don't contain objects, objects also don't contain objects in Python. Objects can only point to other objects. So the list's index 0 points to the integer 9. That's also why, if we put our list inside another list, we'll be pointing one of the indexes in that new list to our existing list. Variables can point to objects, and objects can point to other objects. Nothing ever points to variables. Variables are just a name that references an object. So this third mental model is a bit more complex than the sticky note model, but it stretches a bit further. The indirection between variables and objects is tricky, but it also makes it easier to understand how data structures work in Python. And in fact, I'd argue that of these three mental models, this one is the closest to how Python actually models variables and objects. To better understand the world, it's helpful to consider the mental models that you use. But it's also helpful to consider the words you use. Linguistic determinism is the idea that our thoughts are constrained by the language we use. We can't think a thought that we don't have words for. This is not real. It's not a thing. It is possible to think a thought that you don't have words for. Linguistic relativism is the idea that our language doesn't determine our thoughts, but it does affect them. The language we use can implicitly shape our mental models. There's an interaction that I've had repeatedly over the years. A Python learner will tell me that they've assigned two variables to the same value. And they'll say, and in our case, our variables here are first and second, they'll say that when I change first, it doesn't always change second. When I ask what they mean, inevitably they will show me something like this. Here, I changed first, and second changed. But here when I change first, second doesn't change. Why? The word change is the problem here. Change is accidentally playing two different roles. It's like the word biannually. Do we mean twice a year or once every 2 years? Or ounces. Are we talking volume or weight, half a cup or a quarter pound? With change, we might be changing a variable or we might be changing an object. Assignments change variables, mutations change objects. So, instead of using the word change, I encourage folks learning with me to be more explicit. As the Zen of Python says, explicit is better than implicit. When we reassign first, second still points to the same object. But if instead we mutate the object that first points to, if second points to the same object, then both first and second will see that change. The word change can be ambiguous in Python, and ambiguity can reinforce fuzzy and incorrect mental models. Now, just to drive home the difference between these two types of change, I'd like to revisit that third mental model. For the sake of simplicity, I've removed the extra arrows that would normally be pointing from each index in our list to separate integer objects. It would have just been a lot on this slide. Integers are immutable in Python, so hopefully this oversimplification doesn't really matter. So we've assigned second and first to the same object, which means they now both point to the same 4-item list. When we append to first, the list changes. When we look at second, we'll see that it changed because it points to the same list. But if we reassign first, we're pointing that very list, which means second is unchanged. The second variable still points to the original list, which we didn't touch here, at least not with the second change. This is why the word change is ambiguous. Mutations change objects, and assignments change which object a variable points to. Over the years, I've gradually become more careful about my word choice, at least when teaching. When teaching, I used to use phrases like colors contains a list, or colors is a list. But I found that using these phrases sometimes caused confusion, especially at the point where I tried to teach how variables actually work in Python. Now I usually use the phrase points to. Colors points to a list. This phrase doesn't hint at an incorrect mental model. Now, while the word pointer is a technical term that's not usually used in Python, it's also a term that evokes an idea that we're all familiar with. Brand new programmers and senior developers both seem to understand this phrase. They may not yet understand the mental model that I'm trying to imply with it, but at least I haven't caused confusion unnecessarily by hinting at an incorrect mental model. Your word choice matters. The words we use have implied mental models beneath them. It's probably a mental model that's vague and based on connotation, but it is a mental model. But mental models are wonderful for anchoring your understanding of some small piece of the world within a metaphor. But they are just that, a model. All models have their boundaries. What do your mental models look like? What does your mental model of economics look like? What about immigration or education? You vote based on all of these issues, but you probably have pretty fuzzy mental models of them. I know I do. How might you inspect your mental models to see what's missing or incomplete? And which of your assumptions and beliefs can you revisit? Accept that your mental models are flawed, but also acknowledge that incomplete mental models can still be useful. Our models of the world are always a work in progress. When a more useful model comes along, we should try it out. Let's talk about iterating, but not this kind of iterating. I've given other talks on that topic. Speaking of which, if you're interested in honing your mental model of Python's for loops, that first talk, Loop Better, is the one to check out. I'm talking about the kind of iterating that involves making progress. The Python Software Foundation was formed 23 years ago, and the PSF didn't have a code of conduct for its first decade of existence. But even after a code of conduct was written, there wasn't any official contact information to use for reporting code of conduct issues for the next 3 years. And there wasn't a group of individuals dedicated to handling code of conduct issues until the COC workgroup was formed a year later. But at that point, the code of conduct was only 10 sentences long, and those of us in this new workgroup soon realized that it wasn't actually enforceable until it was rewritten a couple years later. Today, the PSF has an actionable code of conduct with publicly documented processes around reporting and enforcement. And the code of conduct, or issues with the code of conduct, are handled by a dedicated group of volunteers in that work group. But before 2019, the process for addressing code of conduct issues within certain PSF spaces was unspecified. It's sometimes hard not to get discouraged by an exceptionally imperfect situation. I often think of a quote from Hans Rosling: "The world can be both bad and better at the same time." This quote is about acknowledging that we often feel like there's a contradiction between something being less than ideal and better than it used to be. Logically, there's no contradiction here, but it can be very challenging to hold both of these ideas in my head at the same time. Now, this quote is about massive country-level problems, but it also applies to my problems. There is always some way that I could be teaching better than I currently am. So in an effort to improve, I read books about learning and teaching. Learning about a way to improve my teaching abilities is exciting, but it's also nerve-wracking. Right after learning a way that I could improve, I feel a strong urge to immediately improve. Years ago, I read that blocked practice is less effective than interleaved practice. Blocked practice involves dedicating a block of time to practicing one specific topic. Interleaved practice involves jumping back and forth between multiple topics in a single practice session. Many traditional forms of teaching either explicitly or implicitly encourage blocked practice, even though it's less effective than interleaved practice. Now, after learning that interleaved practice was more effective, I wish that I could immediately change all of my curriculum. But I had team trainings coming up and not a lot of time to change everything. So I felt like I had two options. I could either drop everything I'm doing and pour all of my energy into fixing the problem that I didn't even know was a problem a few days before, or I could ignore this information, deny that there was a problem, and decide that everything was as good as it could possibly be. Of course, these weren't my only two options. There was a third option that was more challenging for me to accept, which is that I could appreciate what I had so far and gradually update my curriculum to bring it closer to the ideal version of my curriculum that I imagine might one day exist. I am still working toward that ideal version of my curriculum. My teaching materials are better than they were, but they're not yet where I want them to be. It's hard to acknowledge that I can be making progress, but still not be where I want to be. Or I may not be where I want to be, but I might still be in a pretty okay place. When solving a programming problem, what's the first step? Make sure you understand the problem. But what's the second first step? Break the problem into parts. Python Morsels is a service to help working Python developers level up their skills by solving a real-world Python exercise every week. I launched Python Morsels as a web app in September of 2018. But it wasn't actually started in September of 2018. It started as a paid email list in February of 2018. For the first 6 months of its existence, there was no web app. The website was just a single page with a buy button on it. Of course, it didn't really start in February either. I started beta testing exercises a few months earlier in October of 2017. Though even after the web app launched, there was no way to grade your work, and there was no way to control how many exercises you received and how often. Those features came much later. You've probably heard the phrase minimum viable product. When starting a new project, it's easiest to start with the smallest steps you can, gather feedback, and then iterate. Perfect is the enemy of good, or perfect is the enemy of progress. We often let a vision of an ideal future get in the way of gradual progress. But lasting progress often comes in the form of small steps. Small steps can really add up over time. Now, the gradual path to change isn't an easy one. Until you've reached an imagined future, which may never happen, the fact that you're not there yet feels uncomfortable. But progress isn't just slow, it's also hard to see progress while it's happening. It's easier to see what could be than appreciate what is. This might be a bias that our brains have toward striving for more, which could be helpful, especially evolutionarily. But if we don't occasionally take a step back and appreciate how far we've come, we risk discouraging ourselves to the point of giving up. I'd like to inspect the two sides of this quote a little bit more deeply. The world can be both bad and better. Why mention both bad and better? If we focus entirely on the bad, we risk fatalism. The better helps us appreciate the progress that we've made. It gives us hope. But the bad is what keeps us moving forward. We can't take progress for granted, but we also shouldn't give up on it. Some of the most hopeful books that I have read about human progress have some very critical reviews. Many readers of these books felt that the writing gave them the impression that we can simply sit back and watch progress happen, that progress is inevitable. These readers felt that the books focused too much on the better and not enough on the bad. Positive change is not inevitable. If we focus on the better but not the bad, we risk complacency. Pointing out problems helps us identify the progress there is to be made. On an individual level, to progress effectively, we must believe that we can improve. If you believe that through directed effort you can improve your skills, you have a growth mindset. You think that your skills aren't fixed, but are expandable. That if you put in the right effort, you will grow. The interesting thing about the growth mindset is that you're more likely to learn if you adopt a growth mindset. You're more likely to grow your skills if you believe in your ability to do so. And this isn't some sort of magical thinking that you will into existence this thing simply by believing it to be true. Instead, it's focusing on removing a barrier that our brains can put up. If you see yourself as fixed and unchanging, you're less likely to improve your skills. But a growth mindset isn't something you either have or you don't have. You may think, last year I learned to play the clarinet, so I must have a growth mindset. But Carol Dweck, the psychologist who pioneered mindset theory, has also researched domain-specific mindsets. You may have a growth mindset when it comes to playing the clarinet, but you may have a fixed mindset about the way you communicate with your coworkers. I have one more cognitive bias that I'd like to note before I wrap up, but I'd like to demonstrate it with a question. How much have you changed over the past 10 years? In terms of your personal preferences, your personality, your life goals, and your core values. Now, to help take you back, 10 years ago, it was July 2014. Barack Obama was president. Frozen had just stopped running in theaters. The Ice Bucket Challenge was going viral on Facebook and Twitter. And same-sex marriage was only fully legal in 19 states. The Affordable Care Act was also just coming into effect. And for me, this was just after I attended my first Python conference. It was before I was holding corporate trainings and before I knew what the Python Software Foundation was. Where were you 10 years ago? What was going on in your life? And what were you like? How much have you changed since then? For me, and I suspect the answer for you, is I've changed quite a bit over the past 10 years. But what if I had asked you instead, how much will you change over the next 10 years? What might you be like in July of 2034? How much will you change compared to today? If I had asked you that, you probably wouldn't have said, I'll change quite a bit. This is called the end of history illusion. We tend to underestimate the amount that our future selves will change. Partly this is because it is hard to predict personal growth, because we can't just remember how we were, we have to imagine how we might be. But also, seeing your past self as less mature than your current self feels more acceptable than imagining that our current self isn't fully formed. We don't like to think of ourselves as a work in progress, but we are a work in progress. Change is inevitable. Our brains are constantly changing, whether we like it or not. We may as well embrace that change and try to steer it in a positive direction for our future selves and for everyone else. Today, you are a work in progress. There is progress for you to make, for yourself, for your community, and for the world. Life is short. Enjoy the time you have and try to effect some positive change while you're here. Thank you.